Welcome to Dark Principles Professional Tutorial 1, Installation and Upgrades. In this tutorial we will cover downloading and installing DarkBASIC Professional, downloading and installing the latest upgrades, setting DarkBASIC Professional up for Windows Vista, and finally activating DarkBASIC Professional online. To complete this tutorial you will need an internet connection, your game creator's activation email, at least 400 megabytes of free hard disk space, the latest DirectX 9.0c installed. Please note, for Windows Vista users, DirectX 10 is not compatible with DarkBASIC Professional. You will need to install DirectX 9.0c for DarkBASIC Professional to work. Updates for DirectX 9.0c are released roughly every 2 months. If you get an error message claiming that DirectX 9.0c isn't installed, this may simply mean you need to upgrade to the latest version. Okay, let's get started. Welcome to the Game Creator's website. In this tutorial I will show you how to download and install the software as well as patches. The first thing you need to do, if you haven't done it already, is to create a user profile on the Game Creator's website. Please note the user profile has to match the same email address you used to purchase a product. If it doesn't, it won't show up in your order history. So now we've got that out of the way, I shall now click on Login, which is located at the top there, and you will be taken to a login page. So you type in your details, then click on the Login button. Once you've typed in your details and clicked on the login button, you then are taken to your profile page. So we should now click on Order History. And one thing it's worth mentioning now is if you ever lose your activation key or you want your activation keys, then they are available through this link here. All you have to do is click there, and any products that actually come with the Game Creator's activation keys will be displayed there. So now we're here, we need to actually locate DarkBASIC Professional. There we go. Now the first thing you'll notice is that there's two versions. You have the 11 megabyte version and you have the 90 megabyte version. The 90 megabyte version comes with additional source code and examples, so I recommend you download this one. The other thing you'll notice is you've got download hands-on volume 1 and 2. Don't be confused, these aren't the full books. They're 5 sample chapters of the full books, but I still recommend downloading and reading them. There's a lot of initial information that's worth going through, and of course if you like it enough then you can go and buy the full books in question. Each one is about 750 pages long. So now we're going to download by clicking on the download link. Remember, don't click on DarkBASIC Professional itself. That will take you to a copy of your invoice. You do need to click on the download link, and we shall save it to my downloads folder on Windows Vista, and I'll pause it there so you don't have to go through the entire download with me. Okay, now the software has been downloaded to my hard drive successfully. Now, rather than installing it, we need to go and get the other updates we need. So, go to the top menu and then go to DarkBASIC Professional. Once you're there, go to the Downloads menu option on the left, then click on the Upgrades button. And then we need to start off by downloading the DarkBASIC Professional update itself. You can get away with just installing this and not worrying about the IDE update, which I'll go through in a bit regardless. So we've clicked on there. Now you're taken to the update screen. Just click on download the update. It arrives in a standard zip file, so there'll be no issue there. Download the file. And Save it. Save it to the folder. And there we go. So now our patch has been, or rather the upgrade has been downloaded. We need to get the IDE update. So once again, we return to DarkBASIC Professional. We go to the Downloads menu and Upgrades. And we scroll down the screen and you'll see DarkBASIC Professional Editor Update. So you click on Available here. Now you see the red warning message. You must install 1.0.9 before you install the 9.2 update. The 1.0.9 is actually hidden down the screen a bit, so don't be fooled. Save this one first. Once again, we're shoving it into our Downloads folder. And now we need to download the other update as well. So once again, top menu, then Downloads. Click on Upgrades. And scroll down. Click on the DarkBASIC Professional Upgrade. So now we're downloading the 9.2 update. It's worth noting that there is an alternative IDE that you can download as well, called CodeSarge. Download the file. If you have a look at the Downloads menu again, if you want a more up-to-date editor, then you can again go to Downloads and actually go to the CodeSurge link, or you can do it through the Updates page. So CodeSurge, the alternative DarkBASIC Professional editor. It's a free open source upgrade, I believe. Though it may not be open source. But for the purposes of these tutorials, we're going to stick with the default IDE. So now we have our files downloaded, it's time to install them. Now that we have our downloads in our download folder, we need to start by installing DarkBASIC Professional. And to do this in Windows Vista, all you need to do is double click on the archive. If you have something like WinZip or WinRAR installed on either XP or Vista, it may have replaced a feature, in which case you'll have to extract the file or run it from within the program. So we're going to double click on this now. Don't panic if it looks like nothing's happening. It is extracting the file in the background. There you go, now the file's running quite happily. Windows Vista will come up with a security alert. Click on Allow and you'll have no problems. Unfortunately, this video capture software doesn't capture it because it's in a restricted mode. So now that the install program is running, we'll click on Next. Read through the license agreement, and if you agree with it, click on Yes. Then we want the default location for the software, so we don't want to change that. It's a good idea to choose the default location to install the software to, because if you ever need technical support or you need to locate a file quickly, everyone knows where it is. So as I say, it's a good idea to install it in the default location, and that way if you download anything off the net and or a plugin or whatever, because there are a lot of third-party plugins in the forums, and it gives you a specific directory to copy it to, then obviously you got the default directory, so it's not going to be an issue. So this is now almost copied over. So as you can see by the file names, it's copying a lot of media and demo programs, so you can actually have a look over the source code. Says file association is complete, so we're going to click on OK, then click on Finish. And DarkBASIC Professional is now installed, but the version you have installed is 4.5. So it's worth noting the version you just downloaded is not the latest version. They provide 4.5 for any users who have written code a while ago and don't want to update it to the new language standards. So this basically provides legacy support for any previous source code products that may have been running. So we'll now go back and we need to install the upgrade. Now we're going to do something a bit different here. We're actually going to extract the upgrade. So I'm going to extract it to here. I won't make you sit through it, I'll just pause the video there. So if you're doing this in real time, pause the video and wait for the file to be extracted. Okay, now the file is extracted. We're basically left with a DB Pro update. Now it's important to run this in administrator mode. The reason is because Windows Vista protects the program files directory or folder. If any program attempts to write to that folder and it's not running it in administrator mode, the files are stored in another temporary file in another location and treated as virtual files. With DarkBASIC Professional, it doesn't take very kindly to this, especially when you're installing an update, because obviously the update needs to be overlaid onto the original files in the program. So while the 7.0 update will actually do this automatically normally, I found it a good precaution to always run these updates in administrator mode, and it saves problems down the line. So we're going to do that now. So again, I just clicked on Allow for the security window. We click on Next. The installer will actually locate the default location of the software. It should actually take the correct location from the registry file. So we'll click on Install now, so we don't have to update that, and the files will start copying. And once again, I can't emphasize this enough, by running in administrator mode, you're ensuring that all these files being displayed here are definitely being copied into the program files directory. If we didn't run it as administrator, then these files may not end up in the location they're supposed to. This doesn't happen on everyone's machine, but I do get questions about this every so often. So now that the update's installed, we click on Finish, and to be honest, that's all you need to do for DarkBASIC Professional. You don't need to install the IDE upgrades, but the upgrades do provide a few stability fixes, so it is worth installing them if you want to. But again, they're optional, you don't actually have to do it. So to start off with, we're going to run the 1.0.9 update first, because that's what it said to in the instructions. So again, I'm going to right click on this, and though it's gone off screen, I'm clicking on Run as Administrator, and I've selected the usual security question, Allow. Okay, now we click on Next and Next again. Now this install to location is wrong. It doesn't set it to the correct install location, it doesn't pull anything from registry, and it's using an out-of-date location to install to. So we're going to click on Browse, and as you can see, it's got DarkBASIC software. It's not, it's actually located under the game creators. So we're going to go to Program Files, then the game creators, and we need to go to DarkBASIC Professional Online. Now you may think that's the correct location to install it to. Again, it's not. You have to double click on Editor, otherwise the files will not be placed correctly. So we click on OK now, then next, next again, and this will then install the files. So we've finished that program there, and now we need to install the 1.0.9.2 upgrade, or the B zip file, which is located here. Now we're going to go into the zip file, and the first thing you'll notice is that there isn't actually an installer file. There is an installation txt, but what that basically says is copy the editor file over the editor exe in the program files, sorry, in the editor directory under DarkBASIC Professional. So I'm now going to open up another Explorer window, and I'm going to go into the Game Creators directory, double click on DarkBASIC Professional, double click on Editor again, and as you can see there is an editor file there, so we basically need to copy this editor over here. So yes, copy and replace, and of course it needs administrator permissions to continue, because once again it's writing to the program files folder. So that's now been accepted and it's now copying over, and now we've just manually fixed the editor. So now we've updated it to the full version, we can get rid of these windows and I can close my website browser. Right, now before we run Windows Vista before we run DarkBASIC Professional on Windows Vista, we need to set up the software so it will actually run correctly. Once again, we need to set it to run in administrator mode, because obviously DarkBASIC Professional will be writing exe files to the program files folder. So we do this by selecting the DarkBASIC Pro Online icon with the left hand mouse button and then clicking on Properties. Next we will click on the Compatibility tab, and as you can see I've already done this. I've put a tick in Run the program as an administrator, and just to be safe I've also put Run the program in compatibility mode for Windows XP. So now that's done, we click on OK and we can actually run our software. Now before I go on to actually activating the software, there's something you should know. If your window looks like this, it doesn't have the borders that you associate with Windows Vista, then basically the 1.0.9 patch doesn't work on your system. This does happen on a few Windows Vista machines, mine is one of them. So if your window looks like that, uninstall everything again, and when you update your IDE, either don't update your IDE, use the Code Surge IDE. So we'll close this now and I'll just reinstall it all. Just to be safe, I've returned the IDE to its normal default installation. So now we have the DarkBASIC Professional Activation Service window up. And what we need to do now is click on the Enter Order key button, and we need to type in the email address followed by your order key. I recommend that you copy and paste your order key into this field. It's an awful lot to type out and the code is case sensitive, so you'll understand once you see the activation code. It's rather long, so I'll just quickly type in my details. And paste in my activation key. And next you click on, well, next, and it will say may take several minutes. If you encounter problems at this stage, then it's most likely down to your firewall or internet connection. So as long as you've got a clear internet connection from the program into the TGC server, then there's no issue. But if your firewall is blocking it, then you either need to set up permissions so the software can communicate through your firewall, or you can disable your firewall temporarily. and activate the product that way. But once it's done, you've basically got a fully activated and working copy of DarkBASIC Professional. Now we've set up and installed DarkBASIC Professional, we've activated it, and now we're ready to use it. So we have the main window here, which is referred to as the IDE, that stands for Integrated Development Environment. Basically, it's a text editor that passes along source code to the main compiler, but it does have a lot of neat project management facilities that will help manage and maintain your projects. The first thing you'll see when you load up the editor is that the screen is split into two main sections. On the left hand side you have the text editor. This is basically where you type in your commands. As you can see. And then on the right hand side you have the DarkBASIC Professional Assistant. This is basically the help file to help get new users up and running quicker. So it's worth reading through all this, especially if you're new to the software. And it's quite convenient having it split like this, because you've got your commands on one side and you've got your help on the other side. So if you want to find out about a specific command, you can click on commands, go to core commands, pick something like sync on, and it will give you a list of well, not a list, but a full description and some source code to demonstrate its use. So if you're not familiar with DarkBASIC Professional's command set, then this is a very good way of learning quite quickly. It's like most help file systems. It has a home button, back button. You can copy text to the main clipboard and paste it into the editor, or you can do it itself. It will, if you click on this button, it will copy it automatically for you. And if the command has some example code attached to it, or a project file, you can click on open accompanying project, and that will basically load it into your main text area. You have a few other buttons here. This will take you home. This will take you to the main command menu. This will take you to examples. This will take you to the technical documents, and this will take you to the index. You've got a little find bar here that allows you to search the documents for text. So if I type in cube, I can find all commands with cube in it. So as I say, for someone just starting off, this is a very good way of navigating the help system. You also have a little bar here, sorry, a little icon here that allows you to swap sides if you decide you want it on the left hand side instead. Personally, I like it where it is, so I'm just going to leave it there. You can also adjust the amount of space it takes by dragging this bar back and forth. So now the question is, how do we make a new project? There's one of two ways of doing it. You can either click on the first icon on the toolbar here that will create a new project for you, or you can click on File and click on New Project. You will then be presented with three different options. You've got Auto Configure New Project, so if I type in Hello World there, when I click on OK, it will basically create a folder in the projects directory. So if I go in there, you've got projects directory in there. As you can see, it's empty. Normally there's some example files in there, but for the purposes of this demonstration, I've removed them. So I'll just minimize that. So we've typed in Hello World. We've got the option here to actually specify a folder rather than have it create one, or we can create a new blank project, which basically means it hasn't created any folders or any project data. It just exists in the ether until you save it. It doesn't have a home. And you've got two options over here. Use project view mode is the standard one for most people to use. That will basically replace the DarkBASIC Professional Assistant window here. Or if you want to use the assist view mode, you can do, and that will keep the window there. For the purposes of this demonstration, we'll move over to the project view mode so I can go through that with you. So if I click on OK now we don't want to save. There we go. We now have a window of text. Now don't worry about the rem comments, sorry, the rem command there. That basically sets up a comment in the program. If it's grey like that, it won't be compiled, it won't be executed. It's simply there for your own notes. But what we need to look at now is if we go back into our projects folder, you'll notice there's now a new folder there. If you double click on that, you've now got two files in there, both named Hello World, which is obviously what we called our project. Now the two files are the .db profile is the project management file that doesn't hold any source code. What it does is manage multiple source code files by keeping a list to be loaded whenever the project's loaded. It will also store multiple settings. It will things like how you want your program to be compiled, what sort of data you've entered in there, and lots of little notes. Basically, as I go through the project summary window, you'll see the sort of things that it saves. The DBA file is basically a source code file. You can have more than one of these, which I'll show you in a little bit. I'll close that window now. Don't need that anymore. And I'll start going through the project summary window. The first thing you'll see under the project summary window is the name of the project, Hello World, which we've already set up. Now you can change this quite happily without worrying about it changing the directory structure. So if you call it Hello World 2 whatever, it won't change the folder name, it won't change the file names, it's just something that's stored in the program internally. Exe file name, helloworld.exe. Again, this is basically is used to create an exe file once the program's compiled. So once you've finished writing your instructions into the editor and compiled it, it will be called helloworld.exe. You can browse here. If you click on that, you've got a standard open dialog box, and you can type in the file name and click on save, and it will choose a new file name for you. Project comments, this is just for your own personal notes. So I want to make a program, exclamation mark. So when I save the project file, that will be stored with it. Then we got a to-do list. You right click on that, click on add item, and add an item you want to do. I want to write Hello World to the screen. Now I see I've made that very long, and it will go off the side depending on the resolution and the width of your project summary. Now unlike the assistant view mode, you can't scale this, it's fixed. So if you go off the edge, then tough basically. You either have to make it shorter or you can edit it by clicking on this. As you go, we now have, so there we go, we now have something shorter that fits in there. And you can add multiple items. And as you go down the list and you achieve things, you can put a tick in to remind yourself that's what's been done and this is what you've got to do. Okay, so the next thing we need to do is there are several views to this pane here, as shown down by these 9 buttons. So if we click on settings, you will be presented with the configure exe settings window. Now if you compile your program to run in a window like the IDE does, then you've always got text across the top there. If we compiled our project at the moment, it would just say DarkBASIC Pro project. If we type in Hello World, then when we compile it, we'll have hello world in the caption bar across the top. Then we have exe file settings. Normal exe, small, that's basically just an exe using the existing file structure that's in the project folder. Then we have small exe and pack file. Using the media button, which I'll go into in a minute, you can add media such as sound, graphics, that kind of thing, and include them all inside the program. Rather than carting around lots of separate files, you can put them all into a pack file and an exe file, and then just put them on a disk and send them over without having to copy lots of files over. Or you've got an installer type of exe, which will basically install the file to the user's machine. Exe and attached media. This basically means that it's one big exe file. You won't get any BMP files or media files of any kind, providing you set it up correctly. It will all be inside one exe. You can then compress the attached media to make all the models smaller, make the exe smaller, or you can encrypt them to try and protect them a bit. It's not perfect, but it will provide more protection than if you just give a naked file structure. Okay, then we have display settings. Full screen exclusive mode. I very rarely use this. It basically takes over the display driver and forces the program to focus on the DarkBASIC Professional code only. So it's literally exclusive mode. It will create its own display mode. Then you've got window, which is basically what the IDE is. You can run your program from within a window. Full desktop, it's still windowed. Sorry, you've got windowed desktop. It's still windowed. You'll have a caption bar across the top, but it will be expanded to the entire desktop. Then you've got window full screen. That's without the caption bar across the top, but again, it's still in window mode, so it's not exclusive. It won't change the resolution. And then you've got hidden. Hidden will basically be no window at all, no displays at all. So if you need something that works in the background, this is the option you use. I should say that exclusive mode will change the resolution. So if you type in a resolution here, if you click on that button, you've got a number of resolutions you can change to, depending on what your computer supports. You can just click on another one, or you can use a custom value. You've also got color depth here, so if you want to display in full 32-bit color, you need to click on there and then click on OK, and that will now display at a higher resolution with 16 million colors. As I say, this will literally force the screen to change resolution, so everything will look perfect. If you've got a desktop a window mode open and you change the resolution in that, you may end up with distorted, strange graphics. But again, I tend to use the window mode as standard. So the next one is to click on Edit. This will basically contain all the file information that is encoded into DarkBASIC Professional when you compile the exe. So if anyone looks at the exe and looks at the data within the exe, this is what they'll get. They'll get company name, file description, file version. So anything you type in here will be compiled directly into the exe. The next button down is Files. This is basically where you manage your source code files. Your main source code file is where all the initial instructions are read from, so this is where you have to start setting up the program. Even if you pass it over to another source code file, it will have to be passed over from this file. So the main source code file is quite important. You can add additional source code files. This is very useful if you've got massive projects or big projects that need to be broken down into smaller sections to be more manageable. So if you've got a lot of functions, you can put all of those in a file. If you've got a lot of subroutines, you put those in a file. If you've got a specific area of the program does a specific job, like create textures or make a set of models, or even just contain combat data for your characters, you can add it all in there and give them nice logical file names like combat.dba, and that way you'll be able to manage your data a little bit more effectively. So if we add a new one here, we can type in second source code file.dba. That's something I've typed in previously. Click on save. It will now be added to the list. Now if I want to delete it, I highlight it and I click on delete. Now the one thing to remember about delete is it doesn't delete the file, it just merely removes it from the program list. It won't be compiled and it won't be included in any compiling, but it will still exist. So if we click on browse, we have the file here, so if I double click on that, it's back again. So that's basically how we manage our files. If you double click on it, then you will look at it. If you double click here, then you'll go back to your old project file. You can also swap project files by clicking on this drop down list here. The next button we'll look at is functions. This is basically a list of declared functions within the program. So I'll describe what functions are later on in the tutorial set. For the moment you don't need to know what they are, this is merely a way of tracking them. So if we type in function, my function there, as you can see it appears in the list. So if I was to take that and copy it a few times, as you can see it will appear. So you got the name of your function there, and you got the line of which it appears. If you wish to go to the function, you just double click like that. While I'm on this functions, you can click on view here. If you click on fold all functions, you have to click on it a second time to update it. It will literally collapse all the functions into a tree style list. So as you click that, it will make all the commands between function and end function disappear. You will notice down here you've got 1, 2, 3, 4, 5, 6, then it skips 7 and 8 and goes on to 9. That's because 7 and 8 are being included in the function and just folded away more tidily. It allows you to see what's there without having to go through oodles of data. Again, if you click on view and click on unfold functions, it will expand the tree so you've got all your functions listed. So we'll delete that now. The next button of interest will be labels. Now, any old hats at basic programming who come from the BBC Basic or STOS days or even GW Basic will remember that in order to go to an area of a program you had to know the line number. This isn't the case in DarkBASIC Professional. We use labels instead. So if I type in my label and put a colon after it, that is basically a point in the program we can return to. So if I wanted to go back to line 6 in the program, I've labelled it my label, and I simply type in go to my label, and you don't need to put the colon in, that's only for creating them, and that will then go back to line 6 in the program. Obviously if you're using a go sub command, it's my label followed by return. So if you wanted to go to a label there, you would type in go sub. Whoops. That would then go to my label, run all through the instructions between those 2 points, and then return to line 10 again. So again, I'll go into this sort of thing in more detail later on. So we'll delete that. Next we have variables. Now to declare a variable, you can't just go my var equals 3. it won't show up. That isn't declared as far as the program's concerned. When it says declare, it means specify it as a type. So my var as integer will appear. My var 2 as float will appear. Again, it works in the same way as function labels. You've got a little number here, double click, and it will go to that point in the program. I'll explain variables and what declaring them means at a later point. Then we go on to the media button. This is basically where you add media into the exe ready to be compiled. So if you click on add and then click on browse and select any from of these formats, 2D, 3D, animation, music, sound, it will then be imported into the project. It will actually copy the media into the project directory if you haven't already got it in there by clicking on this button here, pushing a little tick in there, and then clicking on OK. So when the exe is compiled, anything in this list will then be put into the exe. Cursors basically relate to mouse cursors. So if you're creating a fantasy game and you want a sword instead of a standard Windows mouse pointer, you can include them in here and then update the mouse cursor with them. Icons here will allow you to add an icon to your main compiled program. So if you don't like the DarkBASIC Professional standard icon, which is a little black square with a yellow pyramid on it, then you can include an icon or BMP file here. It will then compile that into the exe, and you can have something like a sword or a man or a crown or whatever you want. Often overlooked is the status bar at the bottom. You've got main here, you've got C1 and R6, and you've got the line number, and you also got an indicator that says whether cap lock is on or off. There you go. So if it's on main, that basically means you're on the main source code. If you go into second source code file, you'll see it's got include in there. That means it's included along with the project, but it's not the main file that it's executing from. So if we go back there, it says main. C basically stands for column, R for row. So we're currently on row 6, space, space, space. We got column 4, column 5, column 6. So it's literally just like a spreadsheet or a graph. Obviously, if you go down a line, then you've got different lines. Okay. Next, we'll take a quick look at the menu bar across the top. We got a new project button here, which we've already looked at. We've got open project, which will allow you to open an existing project. We have save source code. This will save the source code, but only the file that's currently open. It won't save any others. If you want to save everything, project file and source code and everything that's open, you just click on that button there. You've got cut, copy and paste. You've got undo and redo, which is quite useful. A number of mistakes I've made in my career. So type in something there, decide you don't want it, click on that, get it back if you decided you really do want it. There we go. We can search for a piece of text throughout the program, so it's very useful if you're trying to find a specific line of commands. You've got search and replace, which will basically allow you to find a piece of text here and replace it with anything here. You've got the direction it searches, so you can search forward or back through the program, or you can search from the cursor or the entire scope of the program. If you've got some highlighted text, then you can only search in that area by clicking on that radio button, or global means it searches everything regardless. You've got options to make it case sensitive, whole words only, regular expressions, prompt on replace, basically means every time you replace something it will ask you, are you sure you want to replace that? We got OK then, we got replace all to do it automatically, and we got a cancel button, which is normal. These are probably the most important. We got this will compile a program, but it won't run it. So you'll just make an exe, you won't get anything else. Exe and run, that will basically create the exe and then launch it afterwards. Run in debug mode. This provides a number of tools for debugging your software. I'll go into that in more detail at another time. We've got step through step mode. That basically allows you to step through the program line by line. This can be useful if you're trying to track down a problem, and again it's another debugging tool, and we already know about this drop down menu here. Let's have a look at the file menu now. We've got new project, which we've been through. We've got open project, which is the same as the button I just showed. We've got open source, which will open a source code DBA file. We've got reopen old projects. We've got save a project, which will save the project file. That's a DB profile, but nothing else. Save project as will allow you to make a duplicate under another file name. Save source will save the source code. So it'll only save the DBA file, it won't save the DB profile. Save source as, again, it will save a copy of the source code that's open. Save all is the one that I use all the time. It saves everything in the project file in the source code. Close will close the current window. Close will close all windows. Remember here, we've actually got more than one window open. We click here, as you can see, we've got more than one source code window open actively. So then we've got close all. Again, we'll close all the windows. Print is fairly self-explanatory. It will print the source code on the screen, and again we all know what exit does. We move on to edit, and we've got the undo and redo commands. We've got cut, copy and paste, which we've already been through. If you want to delete a block of text, for instance, we'll highlight this, click on edit, then click on delete block. That will delete everything. Click on undo to get it back. You can select all in the program, and you can delete block, and again you can undo it. Toggle breakpoint is something you use in debugging, so that's not something I'm going to go into great detail here. You can also set a bookmark, so if you've got an area of the program that's giving you problems, or you need to frequently go back there, or you need to frequently change an area of a program, you can actually set a bookmark here, and then you can go to a bookmark using this menu here. So edit will set, search will find, and that's it for the edit menu. Then we got find, find and replace, find again and find and replace. Again, we've been through these. Go to line will find a line of the program, so if I want to go to line 1 it will go there. If I want to go to the line, whoops, if I want to go to line 2 it will go there, and you can move up and down them that way. And that's basically the search. Then you got view, show toolbar. If you want to increase your workspace, you can disable it, or you can turn it back in. You can do the same with the project manager here. Put it back in. You've got a list of toolbars. You can turn them off individually. So if I want to get rid of the file area, as you can see the icons have gone. If I want to bring them back, then I just put the tick back into it. Display mode. Every time you change this, it has to close a project and reload it again, so you're better off just sticking to the project view mode and pressing F1 to get your help file up. So for instance, if I press F1 here, as you can see, everything that was in your assistant view earlier It's provided in another window. It's also worth noting very quickly, if I type in a command and then press F1 on that command, it will then bring up a window relating directly to that command. So this will now give you all the details you need about print, the description, how to use it, etc. So there you go. We've been through the fold and fold all functions. We've been through the fold and unfold functions now. This is probably the most important one again. Again, it's the same as the 4 icons we just went over. Check syntax, make exe in run in debug mode, run in step mode. Tools, this will basically cover system tools. So you can change a lot of the settings here. To be honest, I wouldn't touch these. You don't need to. It just gets needlessly complicated if you do. So I'll leave these alone. We've seen what window does. I showed you the cascade option. You can tile it horizontally, or you can tile it vertically. It's a good way of managing your projects. Sorry, your open source code windows. Then you've got help, which is what we just saw, the F1. Help content. Again, it just takes you to a different area of the help file, as you can see. Last help file, this will take you to the last place in the help file. So if I go to if I go to the index and I pick a command and then I close it and I can't remember what the command was I wanted, I can just go back to last help file and it will bring up the last command I looked at, or the last help page I was looking at. Then we got index, which will take you to the index of the help file. DarkBASIC Professional Home, this will take you to the DarkBASIC Professional page. If you want to check for the latest upgrades, you just click there. It will take you to the DarkBASIC Professional Upgrades page via your web browser. And this will take you to the Game Creator's Home. This About button is useful because it tells you which version of DarkBASIC Professional you're actually using. As you can see, we're using version 1.07 at the moment, so we'll click on OK. And that is basically the DarkBASIC Professional interface. Now that we know about and how everything works, we're going to start by making our first program. So this is going to be a very simple program. It's the most classic one that everyone learns who learns BASIC or any other program language, and that's how to display the words hello world onto your computer screen. So we type in print space quote hello world close quote, press return. Now we need to put in another command here, because if we just compile it, what will basically happen is it will display hello world, then the program will end. So if I click on this button here, or you can press F5 on your keyboard to compile and run, it will build your program, and that was it. Nothing happened as far as you're concerned. But what really happened is it quickly showed hello world and ended so quickly that you didn't notice. So we're going to type in another command, wait key. This will basically wait for us to press any key on the keyboard, and until we do, the program will just stop. It won't do anything, it won't progress. So we'll click on this or press F5. And as you can see, we have a program here with the words hello world printed. And you just successfully compiled your first program. The final issue I'm going to cover is the color scheme in the DarkBASIC Professional Editor. There are basically 4 colors. There's grey, which is created when you create a remark in the project. As I mentioned before, this isn't compiled into the main program when you hit F5. It's merely for your own reference. Then you have blue, which indicates that a command has been typed in. For instance, if I type in print, it will turn blue automatically. If I type in make object, it will turn blue. If I type in make object cube, it will turn blue. This is very useful because it will allow you to see instantly whether or not you spelt a command right. It's I can tell you from personal experience, in the older languages that didn't do this, you could sometimes spend hours and hours going through a program trying to find that single command you misspelt. It's a very useful feature. The next type of data that will show up as a colour is a string variable, but this will only appear if you put quotes around it. So if I type in hello world, you'll notice it's in purple. This basically means that this is a piece of string data you're passing directly to a command. And the final colour, well, the final but one, is numbers. Numbers will always show up as green, so again, if you're looking for a number in a program, you can easily identify it. The last colour probably isn't regarded as a colour at all, but it is really, is black. So if anything's in black, the chances are that it's a variable name. Because it doesn't appear under the command list, it won't show up as blue. Because it's not in quotes, it won't show up as purple, and because it's not a number, it won't show up as green. So if I want to assign a number to a variable, so my var equals set random numbers, you notice my var is in black, so you'll instantly know that anything in black is almost certainly a variable. If not, then it's probably a spelling error of some kind. Again, the same thing happens for a string variable. See, as soon as I put a $sign after it, indicating it's a string variable, which I'll go into more detail later, yeah, it's still black. So, as you can see, there are 4 different colours. There's grey for remarks, blue for commands, purple for direct string data, green for direct number data, and then black for variable names. So once you learn this code, or this pattern of thinking, then when you come to looking through your code and looking for an area that's giving you problems, your eyes will naturally be drawn to either the command name or the variable data or whatever you're looking for. So it's a very useful feature and something that would have saved me a lot of time had it been around around 1985 or even the late 1990s. So anyway, enough about the DarkBASIC Professional IDE. It's time to actually get into programming so you learn how to use the language. In today's tutorial, I'm going to show you how to install the free edition of DarkBASIC Professional. You start off by opening up a web browser and going to the following web address, www.darkbasicpro.com. And this will then take you to the DarkBASIC Professional website, and you've got a nice big banner here saying DarkBASIC Professional, download it for free. So we click on that, and then we click on the download link there, and it will start in a moment, and as you can see, it's now downloading. Once the download is completed, we just need to open up that screen and open the file, and this will launch the main installer. So you've got the main installer here, and then you click on next and next again, and you don't need the app game kit trial, but I recommend you try it. It's a very useful application, but because I've already got it installed on my machine, I'm going to untick that and then click on next. I'm just going to accept the default installation directory. It's worth remembering this directory because under the projects file is where you'll be saving many of your projects, so you may be visiting this directory in the future. and we'll just click on start, and then everything will install. And then we just leave the tick in Run DarkBASIC Pro and click on Finish. And this will launch the main program. It will do some stuff. And what we need to do now is click on Get Free Order Key. And then we click on Next and type in the email address. And click on Next. This will then contact the server, and I've successfully registered. An email will be sent to me, so we click on Finish there. And what we now need to do is go into our email client. And as you can see, I now have an email with all my details, and if I just highlight this big number here, obviously a lot of it's cut off because I don't want you just taking this one. And we copy that with Control-C, click on Enter Order Key, and we just type in my email address. And paste the key into the box, and there you have it. So then we just click on Next. Order key was verified. There, I can't talk at the moment. Order key was verified. was verified, and we click on Finish. And then that leaves us with our new DarkBASIC Professional editor installed and ready to run. So here we have the DarkBASIC Professional editor ready, set up and running, and I'm just going to take you through the basics of the IDE. For additional help, you can always click on Help, and as you can see, the main help is already there waiting for you. All you need to do is go to Introduction, and that will give you the instruction about the language, and click on Get Started, and you'll get some additional help there as well using debugger languages, and it's worth reading all of this. So we'll just go back. Now this is a tabbed based interface, so if we click between these, we'll get the editor and we'll get the help file. Now so it's worth noting that anytime you want help with a specific command, you can just type in the command, leave your cursor over it, press F1, and it will automatically tell you all about that command. So all I'm going to do here is show you how to type in a very simple program and compile it. And we're just going to type in print, open quotes, hello world, close quotes, and we're going to type in wait key and end. So a very simple program. And we're going to have a look at some of the project properties as well. So to start off with, we'll just go over these panels here. One in particular I wish is to have it in a window form, so it's already in window form, it's already 460 by 480. So if I click on that, I then get my first compiled program. You can also press F5 on the keyboard and do the same thing. Now this isn't a proper project, this is just a temporary project. So what we need to do is actually create a proper project that's saved to the disk. So I'm just going to close both of these tabs, and we're just going to click on File, New and Project, and then we're going to give it a name, Hello World, and we're going to click on OK, and that will then give you a template file. Now what this basically does, I'll just bring up. So if we go into Program Files, the Game Creators, and we go into DarkBASIC Professional Free, and we go into Projects. Sorry, DarkBASIC Pro I need to go into, then we go into Projects, and you'll notice that Hello World has now appeared. Now this is the structure of the files. So we've got Hello World, this is a .dba file, and this is associated with the editor already, and you've also got the project file. Now the project file contains all this information that you set up in these property panels, like so. So what we're going to do is close that, and we'll just go back to our main program. Now we can get rid of this. Rem means remark. This basically means if you type in rem, then you can type anything you like after it, and the compiler will ignore it. So all I'm going to do now is put in my original program, and wait key and end, and I can now compile that at any time I like. So if I now click on compile and run, again it's run, and I'm just going to go back into the project files, and you'll now notice that we've got a third application, which is Hello World. This is the application we just created. So this is the exe that we can run at any time and you can distribute to users. So that's it. Basically, you've got a DBA file. You can tell by properties, and you've got DBA extension there. If you wish to see the extension of the file, you can also press Alt and Shift, click on Tools, Folder Options, and if you go to View and Show Hidden Files and Folders, don't want that one, sorry, hide extensions for known file types, take the tick out of that, click on OK, and as you can see, you now see DBA and exe, so we can now see what our projects are actually called, or what our extensions are rather. So there we go, so we now have that. Now this is one of the main panels you'll be looking for. So this is the properties panel. As you notice, as you put your mouse over it, you get different tags. So do and comments, code view, cursors, etc, etc. So we've got properties there. And if I want to change the resolution, then if I want to make the window bigger, go 800 by 600 for example, then I could just click that drop down menu and it will drop down, and this will start the program in a slightly bigger window. As you can see, that's now bigger than it was, and you can make it really small, and there you go. If you wish to title the project, so if you notice the title of the project is just Hello World up there, so what we need to do, nope, sorry, that's one of the commands. So if you want to retitle your project Hello World, you can do that. Doesn't make a big difference, but it does rename the caption in the window there. So you get rid of DarkBASIC Professional Program and you actually get the name of your application, which is nice. If you wish to assign an icon, then you can do so like that, and you'll actually need an icon file created, of course. I don't have one at the moment, but all you do is you select the icon, click on open, and then it will open up, and the application icon will then change, so it won't just be that black icon with the pyramid on it up there. It will be whatever you set it to. Compress, this basically makes it smaller, so what this does is it compresses any media you set up, and this packages it all up as one .exe file. So I don't have any media to show you in the moment, but if you add PNG files and .x files and WAV files and all that, and you put them into the media manager, which is one of these over here. If you put them all in there, so if I click on that, then I can open up different files and things. They'll all be listed down there, and then anything that is listed there and set up correctly will basically put into a single exe file. So rather than having an exe file and all the supporting files, you'll have an exe file and the files actually combined into one exe. Encrypt basically does the same thing, but obviously it encrypts it, so you can't just decompress the exe that easily. So what these basically do is they decompress into temporary folders. So to be honest, this is no great way of protecting your media. You really want sort of an external program for that, but it is a quick way of just stopping people from just extracting it directly from the archive if you don't want to. Also, we've got version information, so if you want to leave them comments like this: my first program. Company name will be the game creators. Well, I'll just put that in for an example. Copyright, the game creators 2012. Description, the most amazing program in the world. You can just put anything you like, as you can tell, and we'll just call it version 1.0. And that it just adds in a bit of program information. This is all compiled into the exe, so if anyone does a property check, so if we just compile there, we just pop it back into our Hello World folder, right click on that, click on Properties and click on Details, you'll notice that the details we just typed in are now there. So we've got the game creator's copyright, we've got our product version, we've got the product name, and the most amazing program in the world for description. So everything we just typed in is there. So we'll just get rid of that, minimize that, and so that's basically it for that panel. You've got the title, the application name. So if you wish to change the name, so if I want to call it Hello World, for example, and then recompile it again, then as you can see, Hello World appears there. And that's basically that. And over here we have Solution Explorer. This basically allows you to support multiple files. So if I want to add another source code file and call this functions, for example, .dba, then we now have two open programs. So we now have two source code files to work with. So we got our main one there, which is a hello world.dba. Could be called main, could be anything. You can rename it if you wish. Set as main file basically means that is the main file. So if I was to create another file and call that main, then if I right click on that, click on set as main and move that code from there to there and compile it, then it'll start off by using that main file there. And that's basically it for that panel. Again, it's just a way of organizing your files and seeing the file structure. Here is where you add additional media files and things. Because I don't have any prepared at the moment, I can't really show you that. And that's pretty advanced stuff, so you don't really need to worry about it as you're starting out, so I'll just forget about that for now. Cursors will allow you to add specific mouse cursors. So again, if you have a curve file, you'll have to go off and work out how to make those if you want them. But basically, it'll allow you to change your mouse pointer tips to whatever you want. And over here we have doing comments. So if we wanted to do lists, for example, start off by installing software and hello world example, show how to do, and finish tutorial. So obviously these are just a bit random, and you can type in whatever you like here. This is purely for your own note taking. If you want to make comments on this program, like this is a basic hello world program, then you can do that. And basically put in whatever you like, and as you go through the different subjects, you can just put a tick in, and that will all be saved in your project file, so you'll know exactly where you are. So if you're dealing with a very complicated project and you want to work in stages, then this is a great way of organizing your notes and ideas and working through in a logical progression. Obviously you can make things go up and down, you can delete them, and you can edit them, and all that kind of stuff. So quite basic stuff, but very useful. And again, we've got code view here, so if we want to list all our functions, we can do that by clicking on that. Types, labels, variables, errors, constants. Basically, you'll learn about all these as you go through the programming language and learn how to do things. But because I don't have any of that in here at the moment, it won't be listed. But it's just a standard tree view. You just get a list of functions all the way down. Now across the top we've got the toolbar, we've got new. This is create a new source document. So if I click on that, then I can type in a new document and it will appear in the tab, much as I did with functions. We've got open. This will allow me to open additional DBA files. And we've got save, so this will basically save that. And then we've got save all. Now it's important to remember, when you just click on save, you're only saving the .dba file you've got open. If you click on save all, then you save everything across the board. Here we have the standard cut. If you highlight, then you can cut it, then you can paste it. If you highlight it again, you can copy it, then you can paste it again, like that. So pretty standard stuff. We've got print here, which will allow you to print the active document. Again, it will only print the tab you have clicked on. We've got compile without running, so if we do that, it will just compile and make the exe. It won't actually execute the exe. Compile and run, this basically allows you to compile and run the exe. This is the one I use most often. Over here we have the game creator store, so if you need additional content and fresh items like models, desks, and you've got indoor there and horror and all sorts of things. So you've got lots of objects you can download and put into your products. So someone there called cheesecake, and we've got vehicles. So if you want a rusty car, for example, then you can buy a rusty car. So this is a way of getting extra media into your programs, because obviously you're sitting there programming all day, you can't be bothered being an artist as well. So over here we have all the modules that are installed. So what this basically does is, because DarkBASIC Professional is expandable, for example, you've got enhancements, you've got advanced physics, you've got Greenear, you've got easy rotate, lunar, you've got all of these. Basically, if they've got nice colourful icons, you've got them installed. If they're greyed out like this, then you don't have any. If you need to register or activate any, then you just click on that and type in the order key. If you want more information, then you've got the website there, and of course if you want to close it, you just click on close. Here we have indentation, so if we want to increase a line indent, then we do it by highlighting and then clicking on that, and then you can decrease it as well. You can also do it with tab and shift tab. Oh, tell a lie, shift tab doesn't work on this, so that doesn't work. I was thinking of AGK there. So yeah, if you want a tab, then you can do that. If you want to decrease the indent, then you have to select and decrease, and it works like that. If we want to comment the currently selected code, again, if you highlight, then put double slash. That's another way of doing rem. If it's green, then it won't be compiled by the compiler, it will just be completely ignored. And of course, if you want to uncomment the section, then again we need to highlight and uncomment. This is very useful. So if I wanted to comment the entire section out, which I often do in programming, this is a way of disabling that section of the code. And of course, if I want to reactivate it again, then I just uncomment it. Toggling bookmarks is basically if you're dealing with very long source code files and you've got a common place you need to keep going back to, then you can use these bookmarks to go between bookmarks and set bookmarks and remove bookmarks. So if I click on that, it will basically create a little cyan thingy there. If I put one here as well, then I can go back and forth between them like that. And if you're dealing again with very large sections of code and you need to go to common places often, then you can do that. If you want to get rid of it, then you just click on the X there and that gets rid of them all. If you want to remove it, then you just click on this icon more than once and that's done. Here we have, this is the navigation controls for the help file. So if I just press help there, you'll notice all these become active then. So we can go back, we can go forward, standard web navigation controls. You can stop loading the web page because it's dealing as a HTML explorer. You've also got refresh and you've got find. So if you want to find things on the page, then it's that simple. And again, you've got all the usual options for that. So that's the toolbar. Now it's important to note that you can actually adjust these, so you can move them around, you can detach them, so you can completely configure the interface in any way you see fit. You can even add or remove them. So you can add and remove buttons and sort of customize them completely yourself. So I generally just leave it as it is. It saves confusion, especially when you're dealing with teams and things. It's a good idea to keep your interface standard across the board.
So we'll go through the menus here. So again, pretty standard stuff. We've got new project or file. Project will create a complete project, whereas file will just add a DBA file. Open project file, again, same thing. This will open up a whole project. This will just open up a file. You can close the project, you can save the project, you can save the project as. So if you click on save as, sorry, we save the DBA file as, so then click on save as, and that will save the DBA file. And save, of course, will just save the DBA file, not the project. And again, you've got project here as, and that's what you want to do if you want to rename your project. And again, save project there, we'll just save the whole project. Save all, we'll save everything, so exactly the same as up here. And we've got print setup, so if you wish to set up some additional options for your printer, you can do that there. And of course, we've got the magic exit button when you finally had enough of programming. Next we have edit, and we have undo, which is apparently Alt and backspace in this. Normally I use Control and Z, which will get rid of everything, but if we go Alt and backspace, then that does the same thing. So it's just another way of doing an undo. And of course we've got redo, so if we get rid of that and undo, and then we redo an action, so we can basically take back our actions. Now you can do multiple undos, like so, just using Control Z, and we're just going back through the history of random things I did to this program, and again you can redo them all. So that's that. Find is useful if you wish to find a word, especially if it's misspelt. For instance, if you've got a line of dialogue and you notice a particular word is misspelt, you just click on find, type in key, and it will find key for me. If I wish to replace, then I can type in hello world, and I can update it with hello worlds and add an exclamation mark. Click on replace and search select your text only. Is what I got ticked there, which is why it didn't work. So if we click that there, as you can see, that's now changed. That now says hello worlds. And again, if I were to change it back, then I just reverse that. Hello worlds. And that puts it back to where it was. So if you wish to limit it to a particular section of text and it's highlighted, then you can do that, and it will only search the highlighted area of text. For instance, it would only search key there. You can also match case, and you can match whole world. Sorry, whole word only if you wish as well. So pretty standard stuff. Again, replace all will replace all instances of that in the document, which again I found quite useful in the past. And we have bookmarks, which we've already gone through. It's just these up here. Insert and install breakpoint, pretty advanced. I wouldn't worry about all this now, to be honest. You've got some other advanced stuff, like you can go to line, or you can go to project line. Project line basically takes into account all the files, and I never use that in my life, but go to line can be useful. So if we want to go to line 3, then it will take the cursor to line 3 like it did just then. So that can be quite useful if you know the line you specifically want to go to. And again, we've got comment and increase and decrease line indentations, which we've already done up here anyway. We've got some outlining stuff, which again are pretty advanced. I wouldn't worry about all this just now because you're only just starting off. You can enable automatic outlining, line numbers and all that kind of stuff. So if you want to get rid of the numbers over there, you can. If you want to add numbers, then you can. Again, it's not really something you need to be playing with this early on. We got compile and run in debug mode, and we got compile and run in step-by-step mode. So debug is quite useful. That's how you discover what's going in your program. So you basically get this extra window here, and you've got command line interface, variable watcher, so you can list all the variables and stuff that's happening, and you can activate step through mode as well. I'll show you step through mode. So if we go to step through mode, then what this basically does is, as you can see, this program now has a blank window, so it's not actually doing anything. If we then click on step through mode and click on step program, as you can see, you've got print hello world displayed, selected, and then we've got step program again, and as you can see, hello world is now displayed. It's now waiting to execute the wait key command, so we'll do that. And as you can see, all it's doing now is sticking on the wait key command, because it won't go past that point because we haven't pressed key on the keyboard. But if I go here and I do that, then it then exits the program. So very useful if you're not sure which line of code is causing a problem in your program and you're dealing with a relatively short program, then step through mode can work very well. And you can also just play and slow the program. So if you just want to have the program go through very slowly, then just click on slow and it'll just go through everything a lot slower than it usually does. If you want to play it at normal speed, then just click on play program and it will then work as normal. So we've got full screen here. This is basically a view thing, allows you to turn into a full screen editor. Full screen again to get out of it. Toolbars allows you to disable various toolbars. Again, I wouldn't play with this, I'll just leave it as it is. Got the status bar down there, which has now been hidden. We can re-enable it, but that's useful. That gives all sorts of useful information and data on commands. So print statements. It's already given you sort of a quick rundown of the command there already. It also tells you whether cap, num lock or scroll lock is on. Then we got tools. We've got key state helper, and what this basically does is if you press down a key, it then gives you the key number and the ASCII value. If you want to insert that, then it will then be inserted. So if you just get rid of this code, I'll show you more clearly. So key state helper, say I want to know the key state of the key Z, so I'm just pressing Z on my keyboard. It then finds a key state 44 and the ASCII code of 122 if you wish to find it with the char command. So key state 44, just click on insert and it inserts the key state command for you automatically, and this is very useful for users who want to deal with direct input from the keyboard. Without all the get control and enter and all that kind of stuff. So if you want specific keys, then you use that to get them quickly. Command arguments, you don't really need to deal with that now, it's quite early on. Rebuild keywords, if you're having problems with missing commands, if you've installed a plugin or something and the plugin command set isn't working properly, just click on rebuild keywords and all your commands should turn blue then. This is quite common for users who still got account UAC on, user account management. Is it UAC? User account controller, something like that anyway. But basically it prevents access to the root directory. As you can see, I don't have any problems with that on this system. But if you do, then run the program as administrator and then click on rebuild keywords and that will save anything. We've also got associate project and source code files that basically associates .dba and .dbpro files with this editor. We've also got some additional advanced customization options. Again, I would stay quite clear from this. I'll stay quite a way away from that because you can mess up your IDE if you mess around too much. We've got options over here. So again, you can all sorts of things. You can add in folding for functions and loops and things. So if we put in folding, for example, and then type in function, my function. End function, then it should allow you to sort of fold up the functions in the program, but it doesn't actually appear to do that in this particular edition. It's probably because I haven't updated it. But again, lots of things that it's not really worth playing around with. It's best to leave all these things as standard. If you want all your projects to be full screen and you want all your projects to have specific resolutions, and this is a useful one to adjust. And again, if you want to save time, so Daniel Foreman freelance, if I just type that in there, then basically it means that every program now has these as default. Copyright Daniel Foreman. So any project I create now will basically have those details pre-made already. And you have startup and all sorts of other things. But again, to be honest, that's the only one I would risk changing myself, so I'd leave the rest of it alone. Help is fairly self-explanatory. You've got DarkBASIC help, you've got tutorial, so that will open up the tutorial pages, so you've got a bunch of tutorials there you can work through. You've got the main help function, which is all of these things here. Index is useful, that lists all the commands in alphabetical order. If we go back, we've also got some examples you can look at. Commands, you've got a list of commands in categories, so if you're looking for core commands, which is mainly mathematical loops and basically all the core features of the software. Text commands, set text, all that kind of stuff. So now I'll go into this in later tutorials. But the other thing that's quite useful again are these principles that are worth reading through. Data types, operators, common statements, all that kind of stuff is worth reading through when you've got some time. You can also check for updates, so if we click there, as you can see, the software is up to date, so I don't need to worry about that. And if you want to know what version of the editor you're using, then you just click on that and it'll give you about the editor. So build with October 2009, and you got the professional compiler, and this tells you the version of DarkBASIC Professional you're using. So we're using 1.75 at the moment, or 0.75. And that's basically it. The other thing you might want to note is that you've got the main editor there, you've got the code there. You can also change that around. You can put it on the other side if you want. You just drag it to these markers here, and this allows you to move your windows around. And again, same thing over here. So that's quite a convenient way of moving things around. You've got an advert down here. This goes away if you've got the full version of the software. Other than that, this version is exactly the same as DarkBASIC Professional you get with anything else. So Dark Game Studio and DarkBASIC Professional are both the same version. The only difference is you get license limitations, so you can't actually sell any games you make with the free version. You'll need to go and buy the full application, and in the meantime it's ad supported, so they can sort of sell you a bit of their stuff, and that's all really. So as you're getting a free software, which is pretty good, well, it's very good. I built my career on this. So yeah, this is DarkBASIC Professional, this is the IDE, and that's basically all the features that I know of. So so there you go, that's DarkBASIC Professional, and this is the IDE. Oh, I should mention that IDE stands for Integrated Development Environment. So thanks for watching, and please proceed to the next tutorial.
In this tutorial we will discuss and explore the nature of variables. So first of all, what is a variable? Simply put, a variable is a piece of data held within the computer's memory. It can be used to hold the numbers of a shopping bill or the result of a calculation. It can be used to hold a name or an address or anything you wish the computer to remember. As the name suggests, variables can be changed and manipulated throughout any program. It is virtually impossible to write any program without using a variable in some way. The next question is, what type of variables are there? There are three primary types of variables: an integer, a float, or a string. An integer is a whole number. This can be 1, 2, 35, or even 65,543, or anything else you like, as long as it's a whole number. A float is a number that supports decimal points, for example 1.1, 2.2, or 3,403.643, or any other number that is not whole. The final type is a string. A string is basically a collection or a string of characters in a sequence, for example James, John, or 25A Somewhere Road. I will now take you to the IDE, and we can explore how to tell the difference between these different types of variables. Welcome back to the DarkBASIC Professional IDE. Here I will show you how to tell the difference between different variables. So, how do you know what type of variable you're using? Any integer value is a whole number, as I said before, and it's represented by a name. This name could be anything you like, providing it doesn't clash with the DarkBASIC Professional command. In DarkBASIC Professional, it's easy to tell if it does. If the text turns blue, then it's a command already assigned to DarkBASIC Professional, and you cannot use that to hold data. If, however, it's black, then it's usable. Also, please note that variables are case sensitive. To identify an integer to the system, you will have to give it a name without any symbols. For example, my int equals 665782. So my int will now equal that number. As you can see, I haven't put any symbols after the name. I will go through why I mentioned that in a moment. Now, with the hello world command we compiled previously, we pushed a direct piece of string data into the command by putting it in quotes. In this case, I'm just going to type in print, and then I'm going to use the variable name. So if I type in my int, that will now print the content of my int. So now we're going to type in wait key and end. Now let's run the program and see what happens. As you can see, in the same way our hello world box turned up, we've now got a DarkBASIC Professional window with the numbers I typed into the integer. So we'll now close that and go back to the IDE. The second type of variable I mentioned was a float value. That is a number that's not whole, so it could be 1.1, 2.2, as I mentioned before. So we'll just get rid of my int here and my int there, and we'll create my float. Now, the one thing you have to remember with float numbers when declaring them in this way is you have to put the hash sign after it. If you don't put the hash sign, then it will treat it as an integer, and any any decimal points will be ignored. So if we type in 65.665 and then type in my float, again I'm replicating the case exactly, and then we click on compile the program. It will then display 65.665, which is what we typed in. Now if I was to create a second float, my float 2 equals 65.665, and we add in a second command, print my float 2. As you can see, I've left out the hash, but both pieces of data are basically being assigned the same number. So if we run the program again, you will see that the variable assigned with the hash symbol appears as 65.665, where the float assigned without a hash symbol has appeared as 65. So when declaring floats in this way, it's essential to always include the hash symbol after it. The final type of variable we need to pass to the print statement is a string value. String values are defined with a string symbol or the $sign. So if I type in my string and put a string after it, then equals. Now, in order to pass any kind of text data to a string, you have to put it in quotes. You can't simply assign a number to it because your program will crash. I'll just demonstrate that now. If I just type in a random number and then ask it to print my string, the program should crash. As you can see, cannot perform a string cast on that number type. However, if I was to put that data into quotes, regardless of being a number or not, and run the program, it will then display the numbers quite happily. So again, you have to put string data in quotes. And of course, you don't have to just put in numbers. You can type in anything you like. 25A, somewhere road. Put in a bunch of different symbols. Oops, I shouldn't put quotes there. Obviously, you can't put quotes in there, otherwise you'll be messing it up somewhat. Okay, so we'll just compile that. And as you can see, what we typed in with symbols and all is replicated. Again, we'll take a quick look at what happens if you leave the symbol out. So we'll remove the $sign from both of them and then compile them, and again it should produce an error. There you go. Because there's no $sign, rather than having string, it's now got integer in the error message, so that's why you need to include the symbols. So that covers the three primary types of variable data and how to assign them to the program. I demonstrated in the last couple of examples how to hard code a variable, so it's got a piece of data that's simply replicated. However, variables are called variables for a reason. They can be changed throughout the program. So I'll now show you how to do that using simple math statements. So we'll start off with an integer value. So my int equals 1. Now we wish to modify my int. So we can change my int equals my int add 5. So now my int will add whatever data it had previously and add a number 5 to itself. So my int will now equal 6. So we quickly test that. Print my int wait key, compile that, and there you go. You now have the number 6 displayed. You can also use integers in other integer calculations. So my int 2 equals my int add 5, and you can add another one, my int 3 equals my int add my int 2 times 6 divided by 3, just for a bit of fun. And we will now print my int 3. So we get the number 13. However, mathematics isn't always that neat. You don't always get whole numbers. So we'll change my int to my float, and we'll change divided by 3 to 3.5. Again, we'll update the print statement with my float. As you can see, I've accidentally left out the symbol, so I need to include that. So we now got hash my float hash, run the program, and as you can see, we now have a float number. So now we're going to create a very simple, very quick mathematical program. So we're going to take two inputs from the user, and we're going to use the command input. We're going to pass the string value type in a number, colon space. We add the space because if you don't, the number you input will be directly after it. It just looks a bit neater. And we'll input my int there so the user can type in whatever they like. So we've now got input how many times do you wish to multiply it by, comma, and we'll add a int 2. And now we're going to tell the program to basically multiply whatever the first number the user types in is by whatever the second number is. So print, you can actually do this directly within the print statement, my int times by, which is the asterisk key, my int 2, again, wait key and end, click on run, and we now have the program asking us to type in a number. So I'm going to type in 50, I'm going to times it by 44, and you get the number result at the end. So as you can see, variables can be manipulated and reassigned and adjusted in many ways. And obviously if I typed in a decimal number, because I've set them up as integer numbers, it wouldn't have worked. I just got a whole number. So if I change these to my float and my float 2, change these to my float times by my float 2, run the program again, and if I just type in 5 times 5, you get 25 as you would for an integer number. If I type in 5.5 times 9.5, get 45. And the reason for that, of course, is I didn't add the hash symbol. So we're going to add the hash symbol now. See, it's a very easy mistake to make. We run the program again. So 5.5 times 9.5. There we go. We got a proper result now. So as you can see, it's very easy to forget to assign the symbols if you're declaring variables in this way. However, there is another way of declaring them. But we'll get to that in a moment. What we're basically going to do now is demonstrate that you can also perform similar functions to string variables. So we're going to change our program here. We're going to start off by typing in input, open quote, what is your name, question mark. Put a space and a close quote, then comma, name, string. And that will now, the program will now ask what is your name, and you can type it in. So input, what is your town name, question mark, again a space. The reason I'm putting a space after it is if I don't, then when we come to typing in the actual program itself, it will appear right next to the question mark. It's not a big issue, it just looks a bit messy, so it's a good way of avoiding that. So town, string, then input, what is your postcode, question mark, space again, and postcode, string. Now we've got 3 different strings here, and what we're going to do is combine them all into one single string. So information string equals name string. Now we're going to use the add symbol. This will basically add another string value to what we're typing in, to the existing variable we just typed in. So we got name, which will be whatever you typed in, and we're going to add a little bit of text formatting so we can actually mix direct strings with strings that you put into other variables by in the same way that you would for print. So name, we want a comma, then a space, and open quotes, then we put add town string add. Again, we want another quote, comma, space, close quote. The reason we're doing that is when the information string is formatted, it will appear name, comma, town, comma, postcode, full stop by the time we finish. So add postcode string, add again, open quote, full stop, close quote. So we've now formatted information string to include everything we've typed, or everything the user's typed in. It will format it using commas and full stops, and now we will print the result to the screen. So print information string. You can also do the same thing directly in the print statement, so you could get rid of information completely and just copy the name, town, postcode with its formatting and put it directly into the string statement. Wait key end. Now we'll compile the program. Okay, so it's now asking what our name is. My name is Daniel. As you can see, because I put the space in the quotes, it's not right next to the question mark, so it looks a little bit neater. My town name is somewhere, and my postcode is a set of random numbers, doesn't matter what I type in, and press return, and there we go. Print has now taken the information we put in, reformatted, and displayed it on the screen, or rather the information string variable has done it. But as I said earlier, you can do the same thing directly in the print command itself. So as there you got Daniel, comma, somewhere, comma, and the postcode followed by a full stop. However, as I mentioned just now, there is also another way of declaring a variable. So I'll just get rid of this program here, and we're going to declare a variable without without any kind of symbol. So we're going to start off with integer. Now type in my int as integer, and that will now declare my int as an integer. And if you recall, if you click on variables here, the button, my int has now been displayed under declared variables. So that is now what we've called declared. Now we're going to have my float as float. Now as you can see, I haven't used the hash symbol as I normally do. And we're going to have finally my string as string. Again, it's been declared. So now we need to test these variables. So my int equals a whole number, 99855. My float equals 97, sorry, 0.998, and my string equals, putting a bit of data there, my data, then print my int, print my float, print my string, wait key, and end. So I click on run the program, And as you can see, despite not using the symbols, the data is now correct. So we'll close that. And that's how you define a different type of variable without using a symbol. Okay, so I've deleted all that now, and we're going to have a look at other types of whole number declarations we can make. Now there are 1, 2, 3, 4, 5 different types, and I'm going to go through them in order of size. The first thing you will notice is along the bottom here you get some extra data when you declare something. So if I type in my bool as boolean, it displays a number range. So boolean range is between 0 and 1. This basically means that that is the whole size of the number you can actually assign. So you cannot actually go above the number 1 when entering it. However, that's the theory. In DarkBASIC Professional there is a minor bug with Boolean declarations. It means you can actually go higher. So if I was to type in my bool equals 5, print my bool, wait key, end, and run the program, you'll actually get a number bigger than the range specified. This is the only error regarding declarations that I've come across. The next one up is something called a byte. A byte has a range between 0 and 255. So my bool, oops, no, we want my byte as byte. Again, it's been declared under declaration, under the declared variables window, and if you put your cursor over it, you'll notice that the byte range along the bottom is 0 to 255. So we're going to try and assign a number bigger than that. So my byte equals 500. Print my byte, wait key, end, and run. As you can see, the biggest number that's able to be displayed is 244. If we type in 255, which is the maximum range, and we run the program, it will appear as 255. So you do get the whole 0 to 255 range. It's worth noting that you can't go into negative numbers. If it says 0 to 255, then it means 0 to 255. It doesn't include 0 to negative 255. So we'll just quickly test that by putting in a negative symbol and run the program. As you can see, the lowest number it could come up with is 1. So that's produced an interesting error. The next one in the size range is going to be a word. So my word equals, sorry, not equals, as word. Again, you've got the range down here. The word range is 0 to 65,535. So we're going to assign 65,535 to it, to my word. And we're going to print it. And as you can see, you've got the full number range there. Again, if we go above that to 70,000, it produces an error. It can't go up that high, so it's causing a problem. So basically, by the look of it, what it's done is it's actually marked the difference, because it can't count that high. It's basically reset it to 0, then carried on counting. I'll just quickly demonstrate that in a calculator. So if I was typing 65,535 and we add the number that's on screen, 4464, and we get almost the 70,000 we typed in. The reason we haven't got 70,000 exactly is because the computer counts 0 as a number, so it will count 0, 1, 2, 3, 4 rather than 1, 2, 3, 4. So we'll close that down and close the window. The next one in size is a D word, which stands for double word. So my D word as my D word. Again, you got a big range here. You got 0 to a lot of numbers. 4,294,000,000, etc. So I'll just type in that number. 4294967,295. We'll get it to print my D word. There we go. We've got the number we just typed in. Again, if you go over, it should do more or less the same thing. So, 1, 2, 3. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we'll run the program. As you can see, it's counted up from where it was. So, well, not quite, it hasn't in this case, but it's produced a wrong number, so obviously you can't go beyond that range without errors occurring. Now, the biggest number the program can produce is a doubled integer, but before we do that, we'll see how big a standard integer is. So my int as integer. As you can see, that is a huge range. Now, the advantage of this is it will actually go negative as well. So if you assign a negative number, unlike with word and D word and the rest of them we use so far, it will actually support it. So we'll just change print to my int and we'll assign a number to it. My int equals, and there's a number I copied from the documentation I've got over there. However, if we put that in negative and then compile the program, as you can see, you got a little minus sign before it. So we'll actually count from negative 21 billion all the way up to positive 21 billion. So it's very useful if you're using coordinates in 3D space, which we will cover at another point. And the final whole number we can assign is my dint, that's double integer. So we'll just change that to double integer. And again, you've got the whole range there, and it's actually so big it goes off the side of the screen. So you've got, but again, as with an integer, it will go in negative and positive directions. So we'll now test it. So I'll just update that to dint and double int again. We'll replace this rather long number with a ridiculously long number. I'm not even going to attempt to pronounce that one. And we'll click on run. And the number is now reproduced. However, for some reason it's shown in negative. But that's a little quirk of the program, so what we're basically going to do now is drop the number by 1 to 7 there. We'll run the program again. And it will actually display that number in the positive. So it's worth noting, if you use a full number in a double integer, it will actually go negative. So you need to reduce it by 1. Again, if we put a minus in front of it. It will then go into negative numbers. Again, if you're using 3D space and you need a very big coordinate system, then this is the number to use. We're starting off now by creating a float variable. So my float as float. Now you'll notice down here the float range is a little bit odd. It doesn't just give you the numbers like it did for the whole numbers. I'll explain the E system in a moment, but I just want to go over one thing first. If I assign a number, my float equals 0.0001, and then print my float. Again, we're going to wait key and end. If we run the program, no problem, it's displayed correctly. However, if we add an extra 0, we suddenly got a completely different numbering system. I will explain how the E numbering system works in a moment, but there's something else I want to show you first. So that's basically the biggest number you can store in memory, or rather the smallest fraction you can store without having it converted into the E number system. Basically, the biggest number you can have with this number of decimal points is 10. So if we run the program now, 10.0001, not a problem. That shows correctly. However, if we go to 100, it rounds it off to 100. We lose our decimal places completely. So if we take a 0 from this side, and because we've already added it, we've effectively moved it from the decimal point to the whole number side, and we click on run, we now have 100.001. So the smallest fraction you can have accompanying 100 is 0.00, sorry, the smallest number you can have is 001. So again, if we increase the other side by 10 and run the program, it rounds it off again. Again, we lose our decimal places. And once again, if we delete a 0 off this side, it shows correctly. And of course, it will go on in the same state until you hit 10,000. Suddenly it's rounded off, and take away the 0. And suddenly it's not. So the smallest fraction depends on how big the whole number is in front of it. Now if you look at the number of numbers here, or the number of characters rather, you've got 1, 2, 3, 4, 5, 6, 7 units displayed on the screen. Now if we have a look at our float range, you'll notice 7 digits. Now a decimal point is counted as a digit, so you can only actually have 6 numbers plus 1 digit on the screen. Okay, the other thing to note, so if we add another 0 here, we lose our number completely. So we've got 1, 2, 3, 4, 5, 6. We'll add another 0, run the program. There we go, we've gone over to the E conversion system. So it's basically saying number 1, E plus 006. So number 1 plus 1, 2, 3, 4, 5, 6 zeros. So it's basically timesing the number 1 by a million. or rather placing the 6 zeros after the number 1. Again, if we increase by 2 more numbers, we got 0, 8. And again, we look at our number, we got 1 followed by 8 zeros. So it's literally 1 followed by 8 zeros. Now if we type in 1, 2, 3, 4, 5, 6 and run it, we now have 1, 2, 3, 4, 5, 6 and 13 places. So if we go back, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So as you can see, it's 13 slots after 1. Again, we'll look at the number in the mathematical system. It is saying 1.2345 So basically it's counting 2, 3, 4, 5 and 6 as extra zeros or extra decimal places forward. And exactly the same thing goes on in the negative direction. So you got 0.00001. Run the program. And it's now 5 decimal places backwards. So we got 1, 2, 3, 4, 5. Now, unlike the one going in the positive direction, that's 1 point something, that has 5 zeros behind it if it said 5, this will actually place it at decimal point 5 here. So 1, 2, 3, 4, 5. So if it's 0.1 going backwards, then that's it basically. It's got 1, 2, 3, 4, 5 decimal places backwards. If I type in 1, 2, 3, 4, 5, 6, you'll notice that it's still 5. So that's basically saying 5 starts at decimal point 1 and then carries on from there. So it goes 1, 2, 3, 4, 5 decimal points is where 1 is located, and then it's 2, 3, 4, 5, 6. And that's how the system works. Now again, if we have a look at float, we've basically got an option of 38 decimal places. So I can go back 38 decimal points, and it will then show 1.23456 minus 0.38. Okay, I've quickly typed in 38 zeros there, so we will now run the program. Or rather, 1 takes the place of the 38th decimal point. So as you see, so it's 38 decimal points forward of 1, 2, 3, 4, 5, 6. Now if I was to type in some extra numbers here, 7, 8, 9, and then run it, it says exactly the same thing, but you'll notice 6 has been rounded off up to 7. So I say this is basically a way of rounding it off. I say when the E system kicks in, as I say, you cannot go in both directions at the same time. You can only go in positive or negative directions, as indicated here. You can either have plus 38 zeros or minus 38 zeros. You can't have plus and minus, unfortunately. So that's how the float system works. It's very confusing to a lot of people, but now you understand how it's rounded off and averaged. You should have no problems using it. The final way of setting up a variable in a program is to set it up as a global. Then you type in the variable name, my var, and you can still declare it as an integer. and this will basically allow this variable to be assigned to all parts of the program. The reason we do this is if you got multiple source code files and different functions in different places, this ensures that the entire program will know what myvar is, and for this reason it has to be declared at the beginning of every program. The opposite to this would be local. This is only used within a function environment. So as soon as a function starts, that variable exists. Type in local myvar, it will run through its program or through the instructions using that variable. Then as soon as end function is hit, it's disposed of, and nothing else in the program can actually access it. So it's a very good way of storing temporary data in memory while you're using a function. I'll cover functions later on in the tutorial, so you'll understand them a bit more then. So that about wraps it up for this variable tutorial, and I'll take you on to the next one.
Hi and welcome to my bonus Dark Principles tutorial. In this we're going to discuss arrays in more detail. So what we're going to do is we're going to go through a very simple program and I'll show you how arrays work. So we create an array by typing in dim and then we give it an ID or an identifier. So array, and we're just going to call it array. You can call it anything you like. You can call it galaxy, you can call it, you know, my shopping list, whatever you like. Now what an array is if you imagine a block of cells like an ice cube tray, and you put a number in each one of those blocks of ice, or the tray, the little cubicles for the ice cubes. If you just put 1 in there, 2 in the second one, 3 in the second one, then all it does is store that data. So if we just type in array, and we're going to give it a size of 32, and what that basically does is it creates 33 slots. So it's got, you need to remember on this that a 0 is counted as a number, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., rather than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're just going to create a standard integer array. You'll notice I'm not using any symbols or anything, and it works in the same way as normal variables, without a hash or anything. It basically just treats it as as an integer. Sorry. Now what we're going to do is going to create a couple of loops. So for I equals 0 to 32, and array open brackets I equals I. So what we're basically doing here is we created a loop. We'll go into these later, but all this does is count from 0 to 32. Now by putting I in there, we're basically assigning an address, because each one of these will assign to a unique slot, and we're also going to count upwards, so it's just going to be slot 0 equals 0, slot 1 equals 1, etc. So if we go next I, now we want to actually print the data so we can see what we've actually written to our array. So this is now not actually just printing for I, it's actually printing the content of the array. So for I equals 0 to 32, and we type in print array, open bracket, and I and close bracket, and we're just going to slow the program down so it doesn't just display a list of numbers quickly. We actually get some kind of delay in it. So sleep equals 100, and then we're going to type in next I and wait key and end, and we're going to compile the program now, and as you can see it's now counting down. And what it's basically done is put all these numbers into the array. So the other things we can do, of course, is apply mathematics. So we can have it as I times, I don't know, let's go 32 just for a little sense of consistency. And we'll just click on play again. And as you can see, it's now counting in 32s. And all these have been stored into the array. So anytime I want to call up an array, I can do so. So if I get rid of this section here, and we're just going to add in a little bit of logic, all we're going to do is go input and open quotes, select an ID between 0 and 32, and then we're going to get a value, so we're just going to call it my input, and then we're just going to go print, and we're going to type in array my input. And basically what will happen now is when we run the program, if we type in 32, and if we type in 615, then we get the data that was saved at slot 15. So that was 480. Just to test that, we'll just go calc, and we'll go 32 times 15 equals 480. So as you can see, that's now working correctly, and that's displaying the correct result. Now, of course, arrays can hold any data you like. So if I wish to adjust this to support strings, and all I've got to do is type in dim array32 as string, and this will then convert all this from an integer into string. However, the index slot will remain the same. It's only the data that changes. And what we're basically going to do is add in a little bit of code to add in a unique string. Is remove this bit of code here, and we're going to replace it with a random character, or not a random character, but a character designed and assigned by the char command. So if we type in char string, whoops, yeah, I can't type, and basically all the meaningful letters start at position 97. You can test this with the key state helper. Just type in A, and basically starting from A will be ASCII point 97. So we're going to type in 97, add I, and this will basically assign a random character to everything. Now we're also going to adjust this input a bit, so we're just going to put a space there. We're going to put in equals, put in extra space, and that will sort that whole compressed issue up. And if we run this now, then the program is now in memory. It's just generated a random, well, not a random character, but an ASCII character for each slot of the array. So if we type in a random number like 17, then we get R. Now we can make this a little bit more fun, and we can do a random value. So if we just type in my random equals RND 32, and we're just going to go my random, and we're going to put this into a loop. So do and loop, and we'll also put a sync there as well, and we'll get rid of the wait key, and this program will basically just go on forever. So if we compile now, and I haven't taken away the input. I should have taken away the input, my bad. So what this will now do is randomly pick between 0 and 32 all the time, and then just pick it randomly for the array and keep changing. So if we just compile that now, as you can see, what we got now is a string of random letters appearing in our program. So there we go. So basically all it's doing is it's going back to the array, and it's pulling the correct number up. It's pulling the identity of that array slot, then taking the character that's stored in that slot and displaying it to the screen. So this is all working directly from memory. So there we go, that's the basics of arrays. You can also use multi-dimensional arrays. So if we have an array of 32 by 32, and we fill the array this time with lots of random data. So we're going to have array equals, and we're going to have I, comma, J, and we also need to create a second for loop. So for I j equals 0 to 32, and we go next j, and we just sort of extend it a couple of levels, and all we'll do then is we won't have it string, so we get rid of string, and we'll just type in I times j, and we'll adjust this down here as well. So my random 2 equals rnd 32, and we're just going to type in my random and my random 2, and this will then generate some random numbers. So what we're basically doing here is we're creating what's called a multi-dimensional array. Now if you imagine an array as these columns of numbers here, each of these numbers is a slot of data. Now if we have a look at this spreadsheet, so we've got numbers down here and we've got letters over here. Now if you imagine these are also numbers, then you'd basically have an array of 32 numbers by another sets of cells by 32 as well. So this would be 1, 1, this would be 11, 1, 2, 3, 4, 5. So this would be 5, E, 5, 11, and etc, etc. So you get the general idea. So instead of just having one row of data here, we have row in all these slots here, and we simply call it by going 1, 1, or 7, 2, or 10, 5, etc, etc. And that's all we're doing here. Is this is basically a set of multi-dimensional arrays. You've got one array there, you've got two array there, you've got three array there, 4 array there, and you just reference them by their numbers. Now you can also have cubic arrays, which are these sheets here. So you've got that array there, you've got that array there, you've got that array there, and then you've got it all repeated again at another level. So you've got sheet 2, this will be a third one. So if we put in a third ID of 32 there, for example, then you'd have a cubic array. So you'd have sort of all the data filling up sheet 1, then you'd have all this data filling up sheet 2, all this data filling up sheet 3, and of course you can put in 4 as well, so you could have sheet upon sheet, and you basically build up extra sets of dimensions in this way, and you can go pretty crazy with it. But if you take it in the most simplest thing, so if you were creating a very basic sort of Star Trek style game, that you could put in S for this field here, and that would be the player's ship. You could put in a star there, and a star there, and a star there, and that would be the stars. The game could be get your ship to the stars, and you can put in a BH there for black hole, and you can put in enemy ship there, enemy ship there, enemy ship there, and you can basically build up a whole set of data in space, in 2D space, like that. So you've got enemy ships, you've got stars, so the star would be at 7, 2, the BH would be at 7, 3, the ship would be 1, 1, etc, etc. So anytime you move your ship from 1, 1 to say 2, 2, then you've got some characters telling the program what's there, and of course you can update the arrays at any time. You can destroy the ship. Maybe the ship would blow up the sun and create a black hole. You know, there's lots of things you can do, but basically all we're talking about is storing data in memory in this fashion, in this very sort of space kind of 3-dimensional, 2-dimensional, or even 4-dimensional space. So you can just create as many layers as you like. So all I'm going to be doing, just to show you how easy it is to address the memory in this way, is just this little program here. So we just got these numbers there, and all we're going to do is record all this data. So we got I, j there, so it's just going to multiply this by this, and then fill up that data slot, and then we're just going to call these 2 dimensions and just display the data on screen randomly. So if we compile this program, then you've got all this random data, and all it's doing is pulling out the information. So we can further expand it by going my random add a space, add my random 2. In fact, we're going to put a comma there. We'll add a comma in the middle, and and we'll add an equals there, so we'll add their equals, and we'll put in the information there. So all we're doing is we're adding a series of strings and pieces of data together to produce a result. And if we play that now, and I've forgotten the extra plus, so it's worth noting the error messages down here. And we'll play again. We'll make this easier, we'll use a text command, and we'll give it a position of 10, 10. And you'll see these later on in the tutorial, and we'll convert all these to strings, which I'll also show you how to do later on. So for now, just assume this code works. Of course, I haven't cleared the screen, so we'll just close that and fix that error by typing in sync on and sync rate. We'll give it 3 or 4. No, go for 3, and we'll compile that. And we'll need the CLS command as well. So there we go. What we're now doing is pulling out all the data from those particular points in the array. So we've got slot 23, whatever, and it's just pulling out the data that we've applied to those particular slots. So as you can see, this is a multi-dimensional array, or this is a 2D array. You can also have 3D, which is cubed, and you can go to additional levels as well. But that's basically how arrays work, and that's all they do is store information in a very easy to retrieve way like that.
One of our most fundamental talents as human beings is the ability to take data, process it, and then make a decision or judgment based on that data. Computers unfortunately don't have this natural ability. We actually have to tell the computer how to make a decision on things and what data by asking questions. And we do this with a combination of the if statement and various operators. There are 4 basic operators. There's the arithmetic operator, there's the relationship operator, there's Boolean operators, and then there's bitwise operators. However, in this tutorial I'll only be covering the first 3. The first set of operators, the arithmetic operators, are simply mathematical statements. You have 4 primary symbols: plus, minus, multiplication, and division. So obviously we know what these mean. 2 plus 2 is 4. 2 minus 2 is 0. 2 times 2 is 4. And 2 divided by 2 is 1. Relational operators come in 5 symbols. We have equals, we have greater than, we have less than, we have equal to greater than, and we have less than and equal to. As the name suggests, they basically work out the relationship of 2 pieces of data. The next set of operators are Boolean operators. The 3 main symbols for these are and, not, and or. Rather than going into detail about them right now, I suggest you wait until the tutorial section and I'll explain these in greater detail. In order to use the operators we've just discussed, we basically have to start by learning how to use the if statement. And the if statement is basically asking a question. If this is true, then do this. If it isn't true, then do something else. So the basic question we're going to assign is A and B the same. So we're going to type in A as integer and B as integer, and we're going to assign these two integers to whole numbers. So A is going to equal 1 and B is going to equal 1. Now, by our own logical process, we can happily look at A and B and say they are the same, they hold the same data, but the computer won't know this unless you actually ask it the question. So we're going to type in if A equals B. So I've used a relationship operator here, basically comparing the data of A to the data of B, and it's going to come up with a response, yes, A does equal B. So we need some kind of response. So then you type in then, and while it doesn't show up as blue, it is actually a command, and we're going to type in print A equals B. So when it works out that A does equal B, then it will print A equals B on the screen. So we'll quickly test that and you'll see it in action. And as you can see, it's compared the two data, it's decided the statement is true, so it's printed that to the screen. So we'll close this now. Now if we change B to equal 0, then it should work out that A doesn't equal B and then do nothing at all because there's no programmed response for it. So as you can see, the program's running, but it hasn't come up with anything, it hasn't been given any choices, so we simply got a black screen. But this doesn't have to be the case. We can offer the program an alternative if the first isn't true. And we do this by adding yet another command, which is called else. And this breaks up the command into the question, then the first response, and if the first response, if A doesn't equal B, then it will default to the second response. So we're going to print it, we're going to print the line, A doesn't equal B. And now when we run the program, it will run the alternative command. So there we go. But having everything squeezed into one line can be a bit of a problem, especially if you want to use multiple commands. So we can restructure the statement so it looks a little bit more logical, a little bit more sensible. So I'm going to delete that now, and we're going to start off with a question, if A equals B. And we're going to mark the end of the question by typing in end if. And this allows us to use as many lines of the program as we need. So now, if we type in print A equals B, then basically it asks a question, it's going to carry out the command, and when it hits end if, that's the end of the question, and it will carry on the program as normal. So we will run the program now, and of course A is still 1 and B is still 0, so we get no response. So there's still no alternative command typed in. But that's not a problem, we can still use the else statement. So we type in else, and this marks the set of alternative instructions. So we can now type in print A doesn't equal B, run the program, and now it will actually select the alternative. So there you go, A doesn't equal B. It's a good idea to add an indentation before the commands, because it allows you to easily see which commands are occurring in which part of the if statement. If I change this back to 1 and run the program again, it will now select the first option. So there we go, A does equal B. Relationship operators are the most commonly used operators because they allow us to form the second part of the question. For instance, if we just typed in a plus b what? There's no response to compare it to, and we don't know what's going on. So there's no real question there. A equals b, yes, so what? However, if you were to type in a and b equals c, and we add another integer, and we set up c so it equals 2, we'll just change these lines here to a simple yes or no response to the question. So now we know a and b equals 2, therefore it must equal c, so we should have the yes response. So there you go, it's taken two pieces of data and happily compared them to C and come up with a yes response. And if we change C to 3, then we know 1 plus 1 equals 2, so it's not equal to C, and we should get no response. There we go. You can of course use other mathematical operators or arithmetic operators such as minus. Now 1 minus 1 equals 0, so we're now asking the question, does a minus b equal c? Set that to 0, run the program, and it will come up with yes. So it's effectively taken a sum and worked out the response to that sum. And of course, if we turn C to 1 and run the program again, it will come up with no. If I then decide I want to divide these numbers together and I increase these to 2, we both know 2 divided by 2 is 1, therefore we should get a yes response. There we go. And of course, if we change it to 2 as well, C to 2, we will then get a no response. There we go. And finally, of course, you can use the asterisk, which is actually multiplication. And we all know that 2 times 2 is 4, so a times b equals c should come up with yes. There we go. And now we set it to 2, and it should come up with no. So a times b equals c, and the answer is no. So there we go. We've basically been able to create sums here based on existing data, or you could get data from the user, and you've been able to make decisions on it. Is this true? Then do this. If it isn't true, then don't do this, or do something else. So now we know how the arithmetic operators work. We can have a closer look at the relationship operators. And to do this, we'll reduce the program down to its bare minimum to make it a bit easier to understand. And we'll basically ask the question, is A greater than B? And A is currently equal to 2, and B is currently equal to 2, so they're not greater than each other, so we'll get the no response. So there we go. Now if I change A to 3, so A becomes a bigger number, therefore is bigger than B, we'll come up with a yes response. So there we go, we got yes. We've happily compared two pieces of data and worked out which is larger than the other. Another extension of this same theme will be equal to or greater than. Therefore, if I type in 2, then it is equal to B. So A is equal to B, and therefore the equal operator will kick in. So there we go, yes. Again, yes, A and B are equal to each other. Again, if I increase A, then it will be greater than, and we'll still get the same yes response. And the next operator would be less than. So now we're asking the question, is A less than B? A is currently greater than B because it's still set to 3, so we should get the no response. No, A is not less than B. So there we go. And of course, if I reduce A to 1, then it will become less than B, and we can run it. So yes, it is. Again, if I put the equal sign in, it becomes equal to or less than. So if we run the program again, it will still come up with the yes response. But whereas before, if I typed it in so they both match, it wouldn't have come up with yes, it would come up with no. But now that it's equal to or less than, we can, it is yes, so we'll get the yes response. There we go. So now we know how less than works, greater than works, and equals works. You can actually combine the less than and greater than symbols as well. So is A less than or greater than B? So no, it's not. They're both exactly the same value. So it's another way of saying equals, basically. So no, it's not. However, if we change B, then it will become yes, one of the variables is bigger or less than the other one. So there we go. So there are many ways you can use these operators together. Those are the main ways of doing it. You could put in equals as well, but that would basically mean that everything equals everything else. Therefore, there's no point in typing it in. There's no decision to be made. Okay, I'll delete everything there, and we basically move on to the Boolean operators. So rather than having integers, we're going to set up A and B as Boolean. Now what Boolean basically means is 0 or 1, an on or off state. Anyone who knows what digital is basically knows that it's a combination of ones and zeros, and basically those binary that binary data is used to trigger logic gates, and those come in the form of and, or, and not. So we're going to set up this second one as Boolean, and hopefully you'll see what I mean in a moment. Now we're going to set up a little bit of a program here using the AND gate. Before, if you had A and B equal 1, like this, and you put the plus sign in, then A and B together would actually equal 2. We don't go up that high. We're not using that kind of logic. All we're looking here for is inputs. 0 means off. That means nothing there, not live, not working, out. If it equals 1, then yes, we have a live signal. This can be triggered. And the best way to show this is actually with an if statement. So we're going to type in the question if A and B equal 1, then print 1. So we're just looking for basic binary on and off states. Else print, whoops, second line, print 0 and end if. Now because A and B both equal 1, i.e. they both have live signals or are both showing 1s, then this if statement will basically return the state of 1. So wait key and end. So we should now get the response 1 on the screen. Sorry, typed in then. You don't type in then there, you just type in the command. My bad. Thinking too much about the logic. So there we go. We now got a 1 response. Now, if I change any of these inputs to 0, we won't trigger a response anymore. We'll no longer get 1. We'll only get zeros passed back. So there we got a 0 there. And put a 0 here as well. Run the program, you'll still get a 0. And we'll try B's 1 as well. And there you get 0 again. So the best way of looking at it is 0 and 1 equals 0. 1 and 0 equal 0. 0 and 0 equal 0. And 1 and 1 equals 1. That's how we taught to learn it in electronics. So the only possible situation where this command will actually respond with 1 is when both inputs are live. Now you can add more than one input, so we can have a third option here, C as Boolean, and we'll set them all to 1. And we'll set another one in here, and C equals 1. So basically, because all 3 inputs are live, we should get the response of 1. So there we go, we've got a nice healthy 1 there. And if any of these inputs, any of them at all, are set to 0, or all of them are set to 0, then you will no longer get the response of 1, you will get the response of 0. So it will only trigger when all inputs are live, showing 1, being fed into the statement. You might ask how this is useful, but if you want to find out 2 key presses from the user, then you can use a command to get the state of the control key, and you can use a command to get the state of the A key. And if you combine those together with if control and A equal 1, then it will respond with 1, and you can trigger a series of events based on that keyboard command. But if you don't do it that way, then it won't work. So if you only press control or you only press A, then the statement won't be triggered. So it can be highly useful in that sort of situation. So we get rid of the second and there, and C, and we'll go back to our basics. So basically you can use more than one variable, more than one Boolean variable in the first part of the statement quite happily. The next operator we're going to look at is OR. So obviously this is another Boolean operator, and this time we're asking the question A or B. So if you put in the input 2 zeros, for example, as A and B, then this won't trigger it. You won't get a 1. So we'll run the program there, and we should get a 0 triggered. Okay. Now if we set both of them up as 1, so we got a live input on both of them, we get a response of 1 because one input is coming in, or the other input's coming in. Again, if we set A to 0 and B to 1, then it will trigger a 1 response again because one of the inputs is sending a signal. And if you swap it around again, so AC equals 0, so A equals 1, B equals 0, you'll still get a 1 triggered. So it's basically saying is A or is A or B 1? If they are, then trigger the response of 1. So again, the only way not to trigger this statement is to put in 2 zeros, saying there's no inputs coming on in either. So as you can see, you got the response as 0. So again, the best way of looking at this would be 0 or 0 equals 0, and then it will be 1 or 1 equals 1, then 1 or 0 equals 1, then 0 or 1 equals 1. So the only state in which this command or this if statement cannot be triggered in is if both inputs are closed, they're not live, they're not sending ones. So that's the OR statement. Now we're going to have a look at case statements. The biggest drawback to the if statements we've just been looking at is that there are only two choices, two absolutes. So it either is or it isn't, and sometimes you need a third, fourth, or even fifth state depending on the situation. For example, if a black box in a game had 4 effects, for instance, the first effect would kill the player instantly, the second effect would rob the player of half its life, the third effect would add half his life again onto his life, and the fourth effect would give him a weapons upgrade, then you basically have 4 states. So that box would naturally carry the ID 0, 1, 2 or 3. So keeping in line with that, I'm going to create a new integer, my int as integer, and we're going to set my int to 0. Unfortunately, I can't really get into the full game coding right now, so I'll just create a very simple case situation. You do this by typing in select and then typing in the the name of the value you wish to apply to your case situation. So then you type in end select, which works in the same way as end if. Now the difference between end if is you can now create several cases. So case 0, end case. Any commands between case 0 and end case will be executed providing my int equals 0. Case 1, end case. Case 1, so if my int equals 1, then anything that appears between case 1 and end case will also be executed. You can carry on and do this indefinitely for case 2, end case. Again, if my int equals 2, then anything will be carried out from there. You can also set a default case. So case default, end case. So should the my int range fall out of 0, 1 or 2, case default will be put into effect. Of course, any instructions between those 2 points will be carried out. So to make it a little more interesting, we're not going to know which case is selected. So I'm going to replace the 0 with RND, open bracket, 5. So now we could have a random number of 5 at any time generated when when the program first starts. It will generate a random number between 0 and 5. So if it's 1, 2, or if it's 0, 1 or 2, then those instructions will be executed. If it's 4 or 5, then case default will be executed. So we just need to give the case a little bit of code. So print case 0. We'll put print case 1. Next we put print case 2, and finally print out of range. I tend to set the case default with an error message, so if it falls outside the range I expect, then I'll know it's done it, so the program won't carry on giving me errors, and it makes it easier to track things down. So now wait key and end. So basically I don't know which one's going to be triggered, so we're going to click on make exe and run. Out of range, so we've either had 4 or 5. If we run the program again, case 2 has been selected. So there we go. We now have a program that's able to take a piece of data from my int and then produce multiple results based on the data received. You should also note that anything can be put between these lines here apart from another case statement. So you can put an if statement, or you can put anything else in between. Another way of doing it is if you wish to have one case applied to multiple options, you can also put commas. So case 2, 3, 4, 5 and 6 will increase the range to 10, and this case will be case 1 and 7 and 10, and this one will be 0 and 9. So case 0, so basically should my int equal 0 or 9, then case 0 will be triggered. If it triggers 1, 7 or 10, then case 1 will be triggered. If case 2, 3, 4, 5 or 6 are triggered, then case 2 are triggered. If anything falls out of range, then case default will be triggered. So there we go, case 2 has been triggered. And just to confirm this actually is happening, we can also add another line here, print my int, so you get to see which value has actually been chosen. There we go, 10 equals case 1. As you can see, case 1 was selected because it's got 10 there. Program loops are one of the most useful things in the basic programming language. The reason for this is it allows us to do multiple tasks or repeat multiple commands within a loop without having to type them out many times. A simple example of this would be the for loop. So if we type in for, as we've seen in previous tutorials, x equals 0 to 9, and we then type in print x and end the loop with next x, the program will now count from 0 to 9 and then print it on screen. So whereas originally if we didn't use this loop we would have to type in print 1, print 2, print 3, print 4, print 5, print 6, etc. We've now reduced 10 lines of code down to 3. And remember, again, 0 is counted as a number, so you will get 10 numbers on the screen. So I'll progress and type in wait key and end, and then run the program. And as you can see, the program has now counted 10 times. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers on the screen. So again, if you ever want to repeat a set of commands a certain number of times, then this is the one to use. Or if you have a situation where you need to count upwards. You can take the for command even further by using an extension called step. Step will allow you to literally step a certain number of times. So if you imagine taking a staircase, you've got 30 steps going all the way up, but if you take 2 steps at a time, you only actually make 15 steps on the way up. So we type in 2 here, and this should then skip 1. This will then skip every other number that it counts. So if we run this program again, as you can see, it started at 0, then 2, 4, 6, and 8. So we'll close the program now. Step can be increased to any number you like. So if I increase 0 to 1000 and increase the step by 100 and run the program again, as you can see, it now counts 0, 100, 200, 300, 400, etc. all the way to 1000. So if you wish to count upwards in this style, this is how you do it. And of course the step command can also be reversed. So if we go -1 and reduce this down to 0 and then start it at 9, the program should count from 0 to 9 backwards. So we'll run the program. And as you can see, it started at 9, 10, 7, etc. It's counted backwards all the way down from 9 to 0. And again, if you wish to count even further, you can count from 100, from 1000, and you can do exactly as we did before. We can count from 1000 all the way down to 0. So it's a very useful command for this kind of situation. And if you wish, you can also go into negative numbers. So we'll reduce this back down to 0, and we'll go to -1000, because x here is declared as a single variable. It's defined as an integer. So we got the negative number range as well. So we'll click on run. As you can see, it will happily count into negative numbers. Of course, if you want to count into positive into negative, you can do that as well. If you wish to count in decimal points, then you can set it up with 0.1. And remember, to do this you will need to convert x into a float. So we'll now call it x float. And we'll change the numbers from 0 to 1. Run the program. So now we've got it counting in decimals. The next loop is the do and loop. This is an infinite loop that never ends. You don't pass it any conditions or anything. You simply type in do and loop, and we'll do a quick demonstration. Print x and inc x. So this will basically count infinitely until we stop the program. So we'll run it. And as you can see, the program will literally continue counting up until it hits the end of an integer, at which point it will either restart or cause some kind of error. So as I say, there's no way of exiting the do loop unless you use the exit command. So if in key equals s, then exit, and print the loop was exited, and wait key and end. So we'll run the loop there, and when we press the S key it should then end the loop. There we go. So the only way to break a do and loop is to type in the command exit. So exit doesn't end the entire program, end does that. Exit is merely designed to exit any loop you're in. There is another way of mimicking a do loop that the exit command won't have any effect on, and that's to type in a label, for instance start, colon, and then go to start, and if we run this program now and press S, the program won't stop. As you can see, the program will continue going. So that's another way of mimicking the do in loop, but the drawback is that you can't write a get out. You can only press escape in order to close the program entirely. The next loop we're going to have a look at now is the until loop. So we actually start this off with repeat, and we end with the until command. So until x equals 1000. So what we will do now is use the inc command to increase x by 1. So inc stands for increase. We haven't actually defined x as 0, so the program immediately assumes that x will start as 0 and that it's an integer. We will then print x. We'll slow the program down a bit with the wait command. So wait 10. And as soon as x hits 1000, the loop will exit and we'll get the loop was exited message. There we go, it's counting up nicely. As you see, as soon as it hit 1000, the loop was exited, and that was the end of the program. So it's very good to infinitely keep a program going until a certain condition is met. So if you write an if statement, as working out maths or working out a trigger statement such as pressing a key, then the loop will continue going until a certain variable equals the number in question. It can be managed to any piece of data in the program. For instance, if I type in input, quote, the program will end when you type in break, colon, space, quote, comma, then break string. Now if we replace x with break string and make it equal to break, then when we type break into the program, it will continue it will exit the loop. If we type anything else in, then it will just continue indefinitely until break equals the break there. So we run the program. If we type in some random words, pink, cat, orange, nothing happens. But if we type in break, the loop was exited and the program can end. The last loop we're going to look at is called the while. This is dependent on a variable being in existence and at a certain state. So if we type in while space key equals 0, end while. I'll put some commands in here, inc x, print x, just to show it's continuing to loop. Then wait key and end. We need a quick, it's exited. So basically, the space key basically detects whether or not the space key has been pressed. So while space key equals 0, the loop will continue. As soon as we press the space key, the loop will break and the program will exit. This is just another way of using loops. So we'll run the program here. As you can see, the program's quite happily counting along. I'll press the spacebar and that's it, the loop has ended. So this is basically the exact opposite of until. It's saying while this condition is in existence, the loop will continue, whereas the until loop says this loop will continue until this condition is met. And those are the basic 4 primary loop built into basic programming. One of the hardest things to achieve in programming is keeping neat, tidy, understandable source code. By breaking it down into modular sized pieces, it's often a lot easier to troubleshoot specific areas of the program and to write in upgrades. If you just have a solid block of text between a do and loop command, it can be very hard to read, very hard to understand where anything is, and very hard to troubleshoot in the process. So learning how to use subroutines and functions can often mean the difference between a successful large game project or medium game project and a failed game project. Because one of the worst things new users can experience is frustrating game code that they wrote yet they come back to and they can't understand a day later. So to help combat this problem, we will start with a demonstration of the go sub command, and then we'll move on to functions. So we'll create an infinite loop here between do and loop, and we will call forth 2 subroutines. So we'll type in go sub count and go sub display. Now obviously these commands don't actually exist because they haven't been written yet, but we can create them from outside the program loop. It's always a good idea to put end after loop if that's where the program needs to terminate, because if the loop doesn't break, it will go onto the subroutines and cause all sorts of problems. So we'll now create our first subroutine by creating a label, count, put a colon after it, and it will then become the first part of a subroutine. You type in return, and this is what makes it a subroutine. So when go sub goes to count, it will go from there to there, run any instructions between that and return, and then return to where it left off and run the second go sub display command. It will then do the same, return, and carry on through the loop or any additional commands you want to type in there. So for count, we're just going to type in inc x, and then we're going to create our display subroutine. So display colon print x and return. Now this program will count upwards infinitely despite the commands being outside of the main program loop. And when you look at the main program loop here, it's easy to see what's going on. You're starting the loop there, you're then running the count command set, and you then run the display go sub, and it will continue from there on. Obviously with these simple commands it's not massively beneficial, but if you had 100 commands in a block, then it helps to break up your main program and keep it organized. So again, we'll now compile our program and see it in action. As you can see, it's counting as if the commands are in the main doing loop itself. The additional benefit of this is you don't even have to have these subroutines in the main program file. So we can cut all these out, and we can now go to files. We can add a new source code file, call it subs.dba, click on save, and we now have a new source code file. So we can delete all the remarks, we don't need those. We can then paste that in here. We can go back to our main program. You'll notice it says main down here, and it says include here for anything that's included. And we'll compile the program. And you're now working from two source codes, so you can literally keep the functions and you can keep the subroutines separate from the main program to keep it neater and more understandable. As you progress in the program language and develop your own games, you will see the benefit to this a great deal. Now personally, I should note that I don't actually use subroutines myself. Instead, I use functions to create customized commands made up of other DarkBASIC Professional commands. I find it's much easier for keeping tidy source code, and it's a lot more flexible. Hopefully after seeing this you'll agree. So we'll create a new loop, do and loop, and we're going to call two functions as if they're commands. And instead of a colon, we're going to put brackets, and then we've got display brackets. End after loop is always a good idea. And now we're going to create our functions. So function, count, brackets, end function. So any command that's called here will then locate the function and carry out any instructions between it. As soon as it hits end function, just like return, it will return to count. We'll create another one now. Function display. Now if we have a quick look at how the go sub commands looked, to my way of looking at things, that just looks a bit more messy. With count, it's even easier to read, and it helps keep the program as module. However, there are a couple of drawbacks to it, which we'll go into in a moment. Right, so we'll do exactly the same as we did before, treating them as if they're subroutines. Inc x and print x. We'll now run the program and see what happens. Oh dear, it's not counting. What's gone wrong? Well, basically because subroutines don't work in the same way as functions, or rather functions don't work in the same way as subroutines, you can't simply inc x there and expect x there to be remembered, because anything that occurs within a function or is declared in a function that isn't set to global will basically fail because it's considered a local variable. One way around this is to global x as integer and then run the program again. As you can see now, the numbers now work because they're declared as global. That means all parts of the program have access to that variable. You also have an alternative method of doing it. And this is one of the true advantages of functions, is the fact that you can actually pass variables to them as if they're commands. So if we now set x to equal count and we type in x there, so it's passing x into count as well, we will then create a temporary variable in function called temp. We will increase temp by 1 and we will pass temp back to the program, and then we will put x in display and we will create a temporary variable here. We will have this as temp as well, and because it's not passing any data back to the program, you don't need to type the variable after it. So now if we click on compile, again the program will count up quite happily. The hidden advantage in functions is the fact that you can collapse them. So if you've got loads and loads of source code, doing this and treating them as if they're commands is very useful for keeping a project well maintained, modular and easy to understand. And of course, if you want to go back and edit a command afterwards, you can then expand it and expand that, and lo and behold, you can edit the commands. You also have the other advantage that you can store them in a separate file. So if we cut these functions into the clipboard and then click on files, which are already in, click on add. Because the last creation place of a subroutine was the GoSub demo folder, I then have to go into the functions folder and we're going to call it my functions. Click on save. We can then delete all that, paste that in there, and we now have a dedicated file for our functions. And of course, if we click here and go back to the main functions source code and click on run, the program continues as if they had never left the main program. And of course you can pass multiple variables to function. If we go to our functions file there and we create a couple of other variables, temp2 and temp3, then we can then pass 3 variables to this program and process them. And of course the usual standards apply. If you want to pass a string variable to it, you have to set it up as a string by putting the string sign after it. If you wish to pass a float to it, then you hit the hash key. I won't go into too much detail at this point. I just want to give you a basic overview of it, because our final program will use functions quite a lot and you'll get a very good example of how they are used there. But the next couple of examples are going to be fairly basic and won't rely on functions too much.